Hello students, in the last chapter we clearly discussed about classification of matter, yes or no? Both physical classification as well as chemical classification. Physical classification, we have solids, liquids, gases. On the basis of chemical classification, we have pure substances and mixtures. So in this chapter, in detail, we are going to discuss about mixtures. About pure substances also we covered in the last chapter, but once again I will give the definition. So students, answer, what is a pure substance? How can you define a pure substance? Pure substance means the substance which contains only single type of property. It has its own. It has its own. You are the only one. That is pure. If you are mixed, two are there present. That is mixture. Understood? So pure substances are two types. Elements and compounds, students. We already 118 elements are there. Millions and billions of compounds are also there. H2O is a compound. It has its own property or not? Oxygen is an element. It has its own property or not? That's what. They are the pure substances. Then what are mixtures? So mixtures are not coming from anywhere, students. These pure substances only, when they mixed physically, they form mixture. That's it. That means when element mixed with another element, they are not reacting. There is no chemical reaction. Remember, physically means simply they coexist together. They do not form any reaction. Understood? That is called as physical combination. So when these elements and compounds, when they combine physically, that combination is called as mixture. Right, students? Got the clarity? I will give you a few examples. For example, rice is there. Rice. And some stones are there. Rice. Some stones are present in rice. Yes or no? Now answer. Is it a pure substance? No, it's not a pure substance. Why? Because different stones are there, rice are there. Yes or no? Are they chemically combined? Do they form any reaction between them? The answer is no. They are only physically combined. They physically exist. That's it. That is called as a mixture. Right, students? Oil in water. Oil in water. Right? That's a combination, right? Yes or no? Are they reacting? No. Simply that's a combination between oil and water. That's a mixture or not? Two compounds are present or not, students? So mixture means doesn't mean not every time two compounds, two or more in general. But one thing is very clear. It is physical combination. They do not combine chemically. Sir, what happens if they combine chemically? They form a new substance and that substance has its own property. Is that a mixture? Then in that case, no. That's why when these elements and elements or elements and compounds or compounds and compounds, when they mixed physically, they form mixture, not producing. They form, that combination is called as a mixture. So students, let's see the definition. If two or more substances, elements or compounds are both mixed together in any proportion, do not undergo any chemical change but retain their characteristics, the resulting mass is called as mixture. Some of the examples are given, students. Let's see. Air. Air is a mixture. Yes or no? Why, sir? Why air is a mixture? Why? Because air is a combination means not chemically, it's a mixture of different gases. Carbon dioxide, water vapor, oxygen gas, nitrogen gas, noble gases. Yes or no? All these gases are present in the air. Yes or no? Are they reacting in the air? No, they are not reacting. Do they react and they form one single chemical formula of air? No. Air is a combination. Which combination? Physically combined. They physically coexisted in this space. That is air. Air is a mixture. The best example. Next, brass. Brass is an alloy. It's a mixture of different metals. Yes, students. Stainless steel. Steel. Steel, is it an element or is it a compound? No. Steel contains iron, some carbon also, and chromium, nickel. So different types of steels are also there. So that's a physical combination only. Sir, why can't we observe if iron is present in the steel? Why? Because, students, mixtures are two types that we'll discuss in the coming slides. So some type of mixtures are completely mixed, some do not mix completely. That doesn't mean they are reacting, they form a new substance. No. Yes or no? Right. Next, sugar solution, sugar and water. Salt solution, salt and water. Vinegar, acetic acid and water. Smoke means you already know carbon particles present in the air or carbon dioxide. Fog, like suspended water droplets. Cheese, muddy water, river water, hairspray, shaving cream. All these are mixtures only. Sir, what mixtures? You can see, look at the toothpaste, look at the ones, check the backside ingredients, the composition of the paste. You can see it's a combination of different chemicals. That's what the thing is. So they are all mixtures only. Majority we are using the daily life activities, they are all mixtures only, students, not a single formula. You cannot write a single formula for toothpaste. You cannot write a single formula for shaving cream or hairspray. For oil packet also, you can check the back ingredients are there. It's a combination. Are they chemically reacting? No. They simply coexist together. Because of that existence, they have some special properties. But every component which is mixed has its own property. That combination we are using. That's it. Understood? That is called as a mixture. So like I said, mixtures are mainly two types, students. One type is called as homogeneous mixtures. One is homogeneous mixture. Simple. Homogeneous mixture means in these mixtures the components are completely mixed. They are completely mixed. You can't identify the combined elements or compounds also. But I'll give you examples. You answer. Salt solution. Salt added to water. Yes or no? Is it that salt solution, students? Is it like completely mixed or not completely mixed? That means, is it homogeneous? What is other thing? Heterogeneous. Okay. Now answer, is it homogeneous or heterogeneous? The answer is, it is homogeneous. Why? Because salt is completely mixed or not? Sugar solution. Sugar added to water. It's completely mixed or not? Sugar in water. Yes or no, students? Sugar particles are completely mixed in water. For example, sand in water. Sand, is it completely mixed in water? No, that is heterogeneous. Understood? That's the difference between homogeneous and heterogeneous. What is homogeneous? Completely mixed. The component, it's a mixture, combination, and in this combination is they're completely mixed up. That is homogeneous. If they're not completely mixed, simply suspended here and there, sometimes they can form different layers also, like oil and water. Is it homogeneous or heterogeneous? Oil and water? Heterogeneous. Do they mix completely? That's what. So let's see some of the examples. Alloys like brass, bronze. Brass is an alloy of copper and zinc, whereas bronze is in a mixture of copper and tin. If you take a brass alloy, the most familiar alloy is steel. If it can take the steel alloy, can you observe iron where it is? Can you observe the carbon particles? Can you observe any of the nickel, chromium? You can't observe. Why? Because these particles are completely mixed. Are they reacting? No. That is a mixture, right, students? But they are completely mixed. So all the types of alloys comes under homogeneous mixtures. Next, air is a homogeneous mixture. Yes, sir, the best example. Why? Because air, carbon dioxide, oxygen, all the gases are present. Only this is carbon dioxide, this is oxygen, this is water vapor. Can you say like that? No, all are completely mixed up. Right? So better homogeneous mixture. Syrups, ice creams, medicines, face creams, kerosene, all inorganic salts in water, they completely mixed in that particular solution. All these examples comes under homogeneous. What is the point you have to remember when it comes to homogeneous? The components are completely mixed, uniformly mixed. Uniform composition throughout are called as homogeneous mixtures. Second type is heterogeneous mixtures. Now you can easily define the heterogeneous mixture with reference to the homogeneous. Homogeneous is completely mixed. What about heterogeneous is not completely mixed. Sometimes they can form different layers also. Sometimes you can identify each and every component also, like oil and water, which I explained. So sand in water or muddy water? Yes or no? You can observe the sand particles are not in water. Are they mixed completely? No. Kerosene oil or vegetable oil in water? Yes or no, students? You can easily observe the layers of oil and water. Oil and water. Which floats on which floats? Oil floats on water, students. Why? Because oil is lighter and this is denser, water is denser. Paint, soil, blood, starch solution, iron fillings and sulfur mixtures, dyes, etc. all comes under heterogeneous mixtures only. Sometimes you can't observe the different layers. That doesn't mean it is homogeneous. It is heterogeneous only. Paint, blood, starch, this everything, milk is also comes under heterogeneous only. Sand and iron fillings, obviously that is also heterogeneous. Milk is a heterogeneous mixture of fats, carbohydrates, proteins, vitamins and mineral salts, etc. Milk is a white liquid. It looks like a white liquid. It looks like a single compound, yes or no? But milk is a mixture of different proteins, vitamins, carbohydrates, yes or no, students? All these water also, some amount of water is also present in milk in general, not adding, in general. But can you observe all this? No. Are they mixed completely? Means also no. At the particle level, simply these particles are suspended throughout. That's it. So that also comes under heterogeneous mixtures. So need for separation the components of the mixture. We need to, if these particles are mixed, there is a purpose why we mix. Sometimes by the nature they mixed up. So in that cases we need to separate them. Yes or no? Sir, why do we need to separate? I'll give an example. Water. water is there. So while we are getting the water from anywhere, from any source, what we have to do? Sometimes water contains some unwanted impurities present. Yes or no? We need to separate these impurities. That is a mixture, right? That is also mixture, an example of mixture. We need to separate all these unwanted particles or not. That's where the point comes. Separation techniques. We need how to separate these mixtures. For example, milk. Milk can be separated into cream and different components or not. Blood can be separated or not. All these blood components. If you go to the blood test in the diagnostics, what do? They'll separate this blood. So everywhere there is a need for separation. There is a need for separation only. Sea water contains salt and salt water, right? We need to separate salt from sea water or not? We are using salt from where we are getting the salt? From the ocean, from the sea water only. So everywhere there is a need for this separation, and we have different techniques for all these separation to separate all these components. And do we have a single technique? No. Based on the type of components which are mixed, we have different separation techniques. Students, we'll discuss everything. The criteria, remember the main point is, when do we use this separation technique? For which type of examples we have to use this separation technique? This you have to make a point. So here, what is the need for separation? To remove unwanted components, to remove harmful components, to obtain pure and useful component. That's a need for separation. Let's see the first example. Methods for separation in the mixture. First one is threshing technique. Look at the image. Look at the image. Have you seen anything like this, students? In the fields, we'll get all this crop, and this crop contains the seeds, grains, yes or no? That is called as a stalk. That dried off plant is called as a stalk. We want to separate that, all the seeds. How to separate? By hand picking. Can you hand pick the whole acres of? No. Then how to do it? Simply by taking the dried plant and hitting on the slab. What will happen, students? All these grains will be separated or not? That's what that is threshing. That technique is called as threshing. So threshing is a part of harvesting process. The stalks of harvested crop are thrashed against a slab of rock. Is called as threshing. There are different methods of threshings are also there, like foot threshing. Sometimes have you seen on the roads, these stalks are being placed on the road, and all the buses, tractors pass through that stalk. Yes or no? Because of this heavy weight, the seeds, the grains will be separated ultimately. And machine nowadays no one are using this manual threshing. Nowadays everything is machine is separating. So that is called as machine threshing. So different threshing techniques are also involved in this process. Students, next technique is winnowing. So what is winnowing technique? This is also used to harvest in the process of harvesting the crops. Mostly it is used, yes or no? When it is used, in which type of sample it is used, I said criteria. Remember the criteria. This technique is used when, if to separate a mixture, if one of the component in the mixture is lighter and other component is heavier, then we use this technique. When do we use this technique, students? In a mixture, if one is lighter component, other is heavier. So how can you define this winnowing technique? In order to separate the lighter component from heavier component by the force of the wind. For example, husk from grains. How to separate this husk? Husk means the outer layer of the rice grain. Yes or no? That's a very light material. How to separate? This is also olden technique which is followed by the rural parts of the India and all over the world also, students. So by taking this mixture of husk and rice, and by simply from the top, by dropping all this sample, by the force of the wind, what will happen, students? The lighter husk particles will fly away through the air, yes or no? By the force of the wind, and heavier rice particles, grains will fall down. Understood? Of course, this is not a single time process. By repeating the process again and again, what will happen? You can see the lighter particles are being fly away. So we can separate the lighter. Can you hand pick all the husk from grains? No. This is the best technique, by the force of the wind. So this process is called as winnowing. To separate lighter particles from heavier particles is the criteria here. Remember. Next, hand picking process. So students, hand picking, in which cases we can use hand picking? In the previous two examples, can we use hand picking? No, it's not a simple thing to use. Yes or no? Then when we can use hand picking? For a small sample, in that sample, if the components of mixture are bigger in size, if they are powdery, can you separate the powder? No, they should be bigger in size. Just having bigger in size we cannot separate. They should be differentiated by color or even size, then only we can separate. For example, in the olden days also, how can we separate the stones from rice? By hand picking only, students? Yes or no? That is hand picking technique. That is nothing but hand picking technique. So we can separate any sample if with a regular size, with a normal size, and the component should differentiate by color or by the shape also. Then you can adopt this technique called as hand picking. If rice is mixed with any other, if rice is mixed with dal, then how can we separate? We can separate by hand picking or not, students? Simply we can separate. So that's what. So if two components are bigger size and we can hand picking. What is hand picking? Manually taking by hand. That is hand picking technique. So next, sieving process. Sieving process also, in all our homes we use, all our mothers used to do this technique. Yes or no? Mostly from that floor contains some unwanted insects, some dirt particles. Yes or no? When we purchase that floor from the shop, what our mothers do, they use this kind of a vessel kind of thing, and it contains one porous material. Yes or no? It contains small holes. It's like a mesh kind of arrangement. Through these small holes, if they do this zigzag motion, what will happen? All the lighter, smaller size particles will pass through and fall down. It will be collected in another beaker, and what will remain in that mess, students? What will remain? The bigger size particles, unwanted particles, sometimes insects, whatever other impurities are present. Yes or no? Unwanted particles simply. This process is called as sieving. When can we use this technique? Based on the size of the unwanted particles. Based on the size of the unwanted particle. This technique is also we can do during the construction sites also. Have you seen this technique, students? All the sand, they want to separate all the big stones from the sand. As for construction they need sand, right? But that sand is a mixture of some big stones also. What do? They have this iron mesh, and this sand is placed on the iron mesh. They do all this zigzag motion. What will happen? The finer particles of sand will pass through, falls down, and the bigger stone particles will remain. They will separate that out. Understood? That technique is called as sieving technique. This technique works on what principle? Size of the unwanted particles and wanted particles. Next, sedimentation and decantation. So previous all the techniques, students, mostly solid mixtures, right? Solid and solid. Now we are entering into the solid liquid combinations. So what is our technique? Sedimentation and decantation. Very clear. For example, students, muddy water. So take the muddy water. What it contains? Water and mud. Yes or no? And if you keep that muddy water undisturbed for some time, what will happen? During the rainy season, students, if we can observe, the water, the lakes, the nearby ponds, in which color they are in? They are in brown color, almost like a tea color. Yes or no, students? But over 1 month or 2 months, what will happen slowly? The color will changes, the water becomes more transparent. Why? What is happening? All the mud particles which are suspended in water, because of their heavy weight, they will settle down. That process is called as sedimentation. When we can use this technique, students? If there is an insoluble solid present in a liquid, and this insoluble solid if it can settle down, we can use sedimentation. You can see this is water containing insoluble particles. If you keep it undisturbed for some time, what will happen? All the particles will settle down or not? And this liquid is called as supernatant liquid, and whatever the impurities which settle down is called as a sediment. Then how to separate? Simple. By carefully removing the upper layer of water. So this process is called as decantation. By carefully separating upper layer of supernatant liquid from the sediment is called as decantation. So this is sedimentation technique, students. What is the criteria? When can we use this technique, students? The criteria is insoluble solid present in the liquid if it can settles down. Next, filtration. What is filtration? Filtration technique also works based on the same principle. What is the principle? To separate insoluble solids present in a liquid. But if these insoluble solids, they are not settling down. If they settle down, we can use sedimentation. If they are not settling down. Sir, what is the example? For example, sawdust. Sawdust, sawdust, students? Sawdust means if you cut a wooden log, like they used to do all this cutting, students. During this process, we can observe this powdery of wood powder, that is sawdust. This sawdust in water, does it settle down? It won't settle down. Then how to separate it? By using filter paper, filtration. So filtration techniques involves a filter paper. So it's a porous material paper, students, and this filter paper is adjusted in this funnel kind of arrangement. And using this funnel with filter paper, if you pour down all our sample or insoluble solid in this liquid sample, what will happen, students? What will happen? These insoluble particles, can they pass through filter paper? The answer is no. How they can pass? They are very bigger particles. Yes or no? They will remain in the filter paper, and the solution, the liquid particles will pass through, and they will simply settle down in this funnel. And this liquid which is separated from this solution, from this mixture, is called as, using filter paper, this is called as filtrate, and the leftover solid particle is called as residue. Understood? This technique is also used to separate many insoluble solids, mostly precipitate insoluble solids in many chemical reactions. Also this technique is can be used. Understood? What is the difference between sedimentation and filtration? Sedimentation, we have to wait for some time. Filtration, using filter paper, we can separate. Which is the best process? Which is the best process to do? Filtration is the best process. Why? Because filtration is a quicker process. Yes or no? For sedimentation, we have to wait for some time, but filtration, no need to wait. Directly we can do and majority of the impurities can be removed using filter paper only. Why? Because these impurities cannot pass through the filter paper. It's a very tiny porous material. Yes or no, students? Only liquid can pass through. The remaining left over on the filter paper, that is called as residue, and the liquid which is settled down, which pass through the filter paper, is called as filtrate. Got the clarity? What is the criteria? Insoluble solids from liquid solution. Next, evaporation. Students, evaporation is a process. You already know what is evaporation process. To separate the process of conversion of liquid to vapor is evaporation, yes sir, at all the temperatures. But here evaporation is not a process, evaporation is a separation technique. Then what? How can we define what is the criteria when we can use evaporation? For what samples we can use evaporation? Let's see. Evaporation is a technique, students. It is used to separate soluble solids in liquids. Previous two techniques are insoluble. Now we are entering into the soluble solids and liquids. So what are soluble solids? Salt present in water. Salt in water, yes or no? How we are getting salt? Based on this technique only, evaporation only. Of course by the sun, not by heating all the sea water, by the sunlight. Of course manually, if you want to do for simple small sample, we can do by heating also this technique. Taking a tripod stand and wire gauge and taking the funnel with a sample, salt solution is there, and if you, by taking a Bunsen burner, if you heat the solution, what will happen? What will happen, students? If you heat the solution, the water will vaporizes. Salt also vaporizes? No. Water, boiling point how much? 100 degrees Celsius. Do you know the melting point? Melting, not boiling point. Melting point of salt is more than 800 degrees Celsius. Do you think it evaporates? First of all, it cannot convert. It is solid, right, students? First of all, it need to convert into liquid. Then it happens. No. Simply the salt will remain in the beaker. Water will evaporate. We can separate the water and salt solution or not. Sir, what happens to the vapor? They will escape into the air. That's it. This process is called as, this separation technique is called as evaporation. What is the criteria? To separate soluble solids present in the liquid solution, we use evaporation by heating. Evaporation here is not a process, it is a separation technique. So keeping that and waiting for till all get evaporation, no sir, that's not the process, we are heating here, right? Next, gravity method. Sometimes students, between two solids we use a liquid to separate. For example, have you seen students, while every day this happens at our homes, while cooking rice, before cooking rice, what our mothers do? They clean the rice, yes or no? Like they take the rice and they add some water into it. What will happen? All the rice particles will settle down, all the rice grains will settle down. Which will float? Unwanted particles, some insects, some husk particles will float. That is separation, that is gravity method. Let's see. Separation of the components of mixture when either one of the component is lighter and other than the other. One is lighter than the other or soluble in water is called as gravity method. That means grain is heavier, settles down. So husk, is it heavier, lighter, it floats. Ultimately we are separating or not? Is it easy to separate all this husk from the whole sample? No. Simply by adding the water, all the unwanted particles simply float. We can easily separate it. Sir, no. Sometimes based on solubilities also, salt is there and sand is there. Some salt contains some sand particles are there. How to separate? Add in water, the mixture. Add in water. What will happen, students? The salt completely soluble in water. Yes or no? Sand, is it soluble? No, it won't be soluble. Then what? How can you separate? By filtration. By filtering, well, all the sand particles will be filtered. We can get a salt solution. By evaporation, water get evaporate. Will get pure salt or not? This is gravity method based on lighter, heavier, based on solubilities also between two solid samples. We can do in a liquid. So that technique is called as gravity method. So sand and sawdust, charcoal and limestone, sand and salt, like the example which I said, all these technique we can use this gravity method. Next, distillation process. Distillation process, students, this technique we can do for in the case of soluble solids present in liquids also. There is one more technique called as fractional distillation we can use for liquids and liquids also. Let us consider here soluble solid in liquid, salt solution. Sir, we have evaporation, why again distillation? If that's the question, the answer is, students, in evaporation process, if you can check, the vapors are escaping into the atmosphere. Sir, are we collecting the vapors? If you want the vapors also, then how to do it? The process is distillation. How does the process work? So I'll explain. Listen. First of all, students, taking the sample in this round bottom flask, salt solution. The sample contains, students, this sample contains salt solution. Okay, NaCl in H2O. One second. So, is it soluble solid or insoluble solid, students? Salt solution is a soluble solid, right? By heating the solution, what will happen? Like the same process, water gets vaporized. If it is a direct opening, water escapes into the air, we'll get a salt. But we want to collect the water also, these vapors also. Then this is the technique. Look at here. To this round bottom flask, there is one opening which is directly connected to the one equipment. This equipment is called as condenser. It contains one inlet and it contains one outlet. What happens, friend? It contains one inlet, outlet. Through the inlet, cold water comes in. Through the outlet, hot water goes out. Sir, what is this? How the cold water becomes hot? That I'll explain. The vapors which are escaping from this round bottom flask are very hot. Yes or no? And they're entering through this. They're entering, students, through this tube kind of arrangement, and they're traveling through this tube. Yes or no? Now, the glass also becomes hot because of these vapors. Yes or no, students? While cooking, the vessel also becomes hot, right, students? So that's why if you cool down the glass becomes cooled down. That coolingness cools down the vapors also or not? That condenses the vapors or not? Also or not? How can we change vapor to liquid? By cooling. Because of the cold water, these hot vapors were condensed, they become into liquids. And sir, where is heat energy is going into? This cold water takes the heat energy. If the cold water takes the heat energy, now the cold water becomes hot. Sir, if the cold water becomes hot, then the new sample, which is the new gases which are coming, how they become? That's why the hot water, is it staying in this tube, this vessel? No, it is going out. Again, new cold water is coming in. It's a continuous process. Understood? Ultimately, what we are doing here, we are condensing the vapors which are coming from this round bottom flask. Sir, how? By cooling. Ultimately, by cooling effect only, students, water can be, vapors can be condensed. So this process is called as distillation process, and the premises where this process takes place is called as a distillery. Mostly we can see this process of distillation in mostly liquid products factories. For example, alcohols, for example, perfumes, all these kind of industries we can see these distilleries where they can condenses the vapors from the solution, from the mixture. So this equipment is called as a condenser. What is the role? It condenses the vapors which are coming from the round bottom flask. Through the some cold water comes in, the cold water condenses the vapors, and the cold water becomes hot, it goes out. Again, new cold water comes in. So this technique is called as Distillation. What is the criteria? Soluble solids from liquids. We are collecting the vapors also. Next, centrifugation. This technique, students, mainly also used to separate the suspended particles which are present in a liquid sample. For example, blood, milk, these type of solutions, if you want to separate, this is the best technique. So it contains a sample, it contains a glass tube. This is how it looks like. The vessel contains a glass tubes, and these glass tubes are connected to the motor. Why? Because using electricity this technique works, and these glass tubes are moving in a constant speed. So they are rotating at a constant speed. So what will happen, students? For example, students, if any particle is moving in a circular motion, if we are only moving circular motion, what will happen? Will fall down, yes or no? Inside or outside? Outside. That means here also, when the glass tubes are moving in a circular motion, what will happen? It's a mixture. Mixture contains some lighter particles, heavier particles, yes or no? Now where the lighter particles are there, where the heavier particles are there, heavier particles will settle down. They experience a centrifugal force, outward force, and lighter particles will separate it. They will float on the heavier particles. For example, milk. We can separate cream from the milk, yes or no? Where the cream is a lighter particle, does it settle down? It floats, and the remaining heavier particles will settle down. So this technique is called as centrifugation. Why it is called as centrifugation? The outward force is called as centrifugal force. This technique works with electricity, students. It contains rotating test tubes. You can see the sample where the suspended particles are there. If these test tubes are moving with constant speeds, what will happen, students? All these suspended particles, heavier particles, they will settle down. You can see in this image. And these particles are called as pellets, and the remaining lighter particles, suspended lighter liquid, is called as supernatant liquid. This is before image, this is after image. For your understanding, it is given in the same picture. So got the clarity? Rapidly rotating motor. So this technique is centrifugation, used to separate. If you visit to the diagnostics or anywhere, you can find these centrifugations only. So to separate suspended particle, that is the criteria here. Examples, blood or milk. Next, magnetic separation. This technique is also very simple technique. Here in this case, students, to separate a magnetic material from a non-magnetic material, we can use magnetic separation. For example, iron, sulfur. Iron is mixed in sulfur. Which is a magnetic material? Iron is a magnetic material. What about sulfur? Sulfur is non-magnetic, yes or no? This mixture contains iron and sulfur. Then how to separate? Can you separate hand picking? Can we do all the previous technique? It doesn't work. Both are solids, right? Then we can use by magnet. Why? Because iron being magnetic material, it will get easily attracted towards a magnet or not. So that's how we can separate the magnetic material from the non-magnetic material. Sir, how they can separate in industrial scale? In industries, for big samples, they cannot do all the magnets, yes or no, students? So even for separate in the waste materials, to separate all this iron, they use this big magnets only. But industrially, students, this technique is followed by a machine. It contains two wheels. One wheel is magnetic wheel, other one is non-magnetic wheel. Both the wheels are connected by a moving belt. And this belt is moving in this direction. If you place our sample on this moving belt, the sample contains iron and sulfur. Okay, thus the belt is moving. What will happen, students? All the iron particles which are present in the mixture, they will attach to the wheel, yes or no? They will attach to the wheel. What about sulfur? The sulfur being non-magnetic, it simply falls down here. One second. The sulfur being non-magnetic, it simply falls down here. Why? Because it is non-magnetic, it doesn't attaches. Here sulfur will be collected, and the attached magnetic material, and when it comes down, now the belt is moving away from the magnetic wheel or not? They lose magnetic field or not? They will fall down here. Here iron will be collected. Like, is it a single time process? No. By repeating the process again and again, we can separate magnetic materials from non-magnetic material. Industrially this is followed. In general, manually, this is the technique using bar magnets. So got the clarity about magnetic separation. What is the criteria? Magnetic, non-magnetic mixture, we use magnetic separation. Next, sublimation. You already know the process of sublimation, yes or no? What is the process, students? Sublimation is a direct change from solid to gas. Is called as sublimation, right? but here sublimation is not process, sublimation is a separation technique. So you already know the criteria. What is the criteria? If in the mixture, if one compound is sublimable substance and other compound is non-sublimable substance, then we can use separation. Sir, how to do? Very simple, by heating only. Sir, now how do sublimation works? Solids converts into gas by heating only, students. So in case our sample contains sodium chloride mixed with iodine, iodized salt. Have you heard about that iodized salt? If you heat that mixture, contains sodium chloride and iodine, what will happen? The iodine will vaporizes. Why? Because iodine undergoes sublimation. Does the salt vaporizes sodium chloride? No. So that is sublimation technique. That's what I said in the beginning. What I said, there are different separation techniques. All these separation techniques are being followed because of different samples. Every sample has its own nature. Yes, sir, here this is the nature. One is sublimation. So then we can use sublimation techniques. You can see this inverted funnel which is closed. Why? Because if you want to collect the vapors also, these vapors will be collected on the linings of this funnel, and the remaining non-sublimable material is left over in the funnel bottom flask. And in the funnel, all the sublimable material is simply attached to the linings. Later it can also be collected. So what are the examples of sublimable substances like iodine, naphthalene balls, dry ice, ammonium chloride, all these components, camphor. So all these undergo sublimation. What is the criteria? To separate sublimable substances from non-sublimable substances. Example also I gave, iodine from sodium chloride. Next, separation of immiscible liquids. Immiscible means these liquids do not mix completely. They form layers, oil and water. You can see upper layer, lower layer. Sir, no. Blue color and green color. Oil and water is the best example. How to separate oil and water? Can we do hand picking? Can we do filtration? Can we do evaporation? No. Then how to do? Separating funnel. It's a funnel, that's it, nothing heating or nothing is taken here. It's this shape of funnel, it contains one opening, students. And now if we place the mixture and if you keep it for some time, what will happen? Simply oil settles at the top upper layer, water settles at the bottom layer. Sir, now take one more flask and open the tap. What will happen? First, which liquid comes down? Water comes down. Sir, but it is a mixture, no? Right? We are not collecting the whole sample. We have to collect till here. In this picture, it's not so clear. I'll show you here. Okay, this is the sample, students. This is the tap arrangement. These are the two layers. This is oil, this is H2O. And we have to take one more beaker here. If you open the tap, first, which liquid comes down? Water. Yes or no? Sir, but there is a layer. Yes. Can we separate exactly the layer? Can you exactly separate the layer of what? No. So you can collect till the layer of separation only. That means here, till here you can take. You cannot exactly separate. That means some of the water you have to left. Just below the layer level only you have to collect. Once the whole H2O is collected, take the beaker out. Then what is remaining in the funnel, the separating funnel? We contain oil and this some amount of water. Yes or no? Now, how to separate? Take one more beaker, collect this layer. You have to, students, we have to collect this layer of separation, the layer of oil and water in a beaker. That means it's a small wastage only. Here the layer is big. When it comes down, the size of the layer becomes very small or not? We have to, that's a waste. We have to separate that layer of oil and water. Once this layer is collected in another beaker, now in the funnel what is left? Only oil, that is collected in the third beaker. Understood? First water till where? Just below the layer of separation. Not exactly layer of water you cannot separate. Water will be collected. Now what is left? Oil and some little amount of water. That oil and the little amount of water, that layer of separation is there na, you have to take that layer separately in the second beaker. Why? Because you cannot separate that layer of oil and water. Once that layer is separated, what is left? Only oil is left. That oil you have to collect in the third beaker. So 3 beakers are needed for this separation. No heating, nothing is in, no filter papers or anything else. That's got the clarity, students? That's how these immiscible liquids can be separated, and this technique is called as separating funnel. Based on funnel, by tap we can separate. Next, the last technique, chromatography. Chroma means color. This technique works based on separating colored components. For example, dyes, inks, their mixture of different colors or not, and different colors have different densities or not. So, taking a sample of filter paper, this is a filter paper, and by taking this mixture of ink or dye, taking a dot, placing this dot of mixture on this filter paper, and if this filter paper is suspended into the water, what will happen, students? The filter paper is placed under the water, some part of the filter paper is into the water. Then what will happen? The filter paper absorb the water or not? Yes, the filter paper absorb the water. The water pass through this layer of filter paper or not? Correct. Through this process of the passage of water, these dots we have these dots. These dots is a mixture of different colors. What will happen? Do all the colors move at the same rate, same speed? No. Different colors have different densities. Why? Because different molecular formulas. Understood? So the one which is lighter can easily fastly go through. The one which is denser, can it move easily? No. That's how we can separate the colored components based on their densities, based on the rate of movements also. Using the filter paper, there are different papers also. Here we have given the filter paper. This technique is called as chromatography. The colored components based on their densities and the rate of movements, we can separate the colored components. Examples are inks or dyes. So that's it, students. Almost all the techniques we covered, and what I said, mainly for every separation technique there is one criteria, there is one condition. Why do we need to use that technique only? You have to remember that conditions as well as the examples for each and every technique. I hope you got the clarity, students. So thank you. We'll meet in the next video.